Beneath the ground, across oceans, and through cities, the world's biggest machines don't just break records, they invent them. These are the giants that move 12,000 tons in one breath, dig deeper than any human, and cost more than skyscrapers. Each was built for a single reason: to do what ordinary machines can't, no matter the price. But what drove us to engineer such colossal, costly power, and which machine truly pushed human ambition furthest? Every mega machine starts with a challenge. How do you move, lift, or cut something so massive that old tools simply snap or stall? The answer begins long before the first bolt is tightened. It is the story of hydraulics, where pressurized fluid multiplies force until a single lever can tip mountains. It is the rise of digital control. Computers and sensors now track every load, every movement, and every fault, pushing these giants closer to their physical limits while keeping operators safe. Underneath it all lies steel, but not just any steel. High-strength alloys engineered for fatigue and shock form the bones and muscles of these machines, letting them survive years of brutal, cyclic loads that would destroy ordinary metal. As global demand for minerals, energy, and infrastructure exploded, engineers had to scale up everything: frames, engines, control systems, just to keep pace. The result is a lineage of machines that are not just bigger, they are smarter, stronger, and built to take on jobs that once seemed impossible. This is the foundation that makes the world's most powerful and expensive machines not just possible, but necessary. Bagger 293 towers over the Hambach mine in Germany, a machine so vast that it stands 96 meters high and stretches 225 meters from end to end. Weighing roughly 14,200 metric tons, it is the heaviest land vehicle ever built. With just 5 crew members at the controls, Bagger 293 can strip away more than 8 million cubic feet of earth every day, its bucket wheels spinning relentlessly as conveyors carry the load away. Big Muskie once ruled the coal fields of Ohio, a walking dragline excavator that weighed over 13,000 tons. Its boom stretched nearly 150 meters, and its bucket could scoop 220 cubic yards in a single pass, enough to fill a swimming pool. For decades, Big Muskie's electric motors and steel cables moved millions of tons of overburden, rewriting what was possible in surface mining. Caterpillar's 6090 FS brings a different kind of power to the pit. This hydraulic mining shovel packs about 4,500 horsepower and swings a 52 cubic meter bucket, enough to lift nearly 100 tons of rock in one bite. Operators rely on high-pressure hydraulics and ultra-tough steel to keep the machine running day and night, matching pace with the world's largest haul trucks. BelAZ 75710, built in Belarus, is the king of mining trucks. Its rated payload is 450 metric tons, and fully loaded, it weighs over 800 tons, more than a loaded Airbus A380. Two 16-cylinder diesel engines feed power to electric drive motors, while tires taller than a person absorb the shocks of rough terrain. Each run turns weeks of manual labor into minutes, redefining what a single operator can accomplish with the right machine. Liebherr's T282 haul truck is engineered to carry payloads up to 363 metric tons, using a diesel-electric drive system that channels thousands of horsepower to each wheel. Its massive frame, built from ultra-high-strength steel, absorbs shock from uneven mine roads, while onboard computers balance traction and braking in real time. Every run shaves hours off material transport, turning what would be a convoy of smaller trucks into a single, relentless workhorse. Komatsu's D575A3 superdozer stands ready to reshape the landscape. With a blade capacity of 69 cubic meters, the largest ever put on a production dozer, it can push entire ridges of overburden in one pass. The dozer's reinforced undercarriage and high-traction tracks grip loose soil and fractured rock, letting operators cut new roads or flatten stockpiles that would stall lesser machines. Its 1,150 horsepower engine delivers the raw force needed to keep up with the world's biggest shovels and trucks. P&HL 2350 loader completes the trio, bridging the gap between haul trucks and shovels. This wheel loader can lift 72 tons in a single bucket, cycling load after load with hydraulic arms built to withstand years of brutal duty. Its articulated chassis and advanced steering let it maneuver in tight spaces, feeding trucks or clearing debris in record time. Planners rely on the loader's cycle efficiency and reliability to keep the entire site moving, knowing that downtime here means millions lost. Together, these machines form the backbone of modern mining, where mobility, sheer power, and precision engineering drive productivity to new heights. Lifting 100 tons is routine. Lifting 1,000, with no margin for error, is a different order of magnitude. The Liebherr LR 11350 crawler crane is built for these moments, 1,350 tons at its limit, with a hook height reaching 220 meters. Wind farms and industrial plants rely on its lattice boom, each lift calculated down to the decimal. Every variable, wind, ground pressure, and load path, scrutinized by planners who know a single misstep can cost millions. When the job outgrows even the LR 11350, the Mammoet SK6000 ring crane steps in. Its modular ring track distributes the weight of refinery modules and offshore platforms, up to 6,000 tons in a single lift. Electric drives give operators the control to set down a load with millimeter precision. The SK6000 ships in pieces, assembles on site, and breaks down for the next mega project, a $100 million investment that pays for itself in months saved and risk reduced. Taisun, the world's strongest gantry crane, dominates a Chinese dry dock. With a record lift over 20,000 tons, Taisun lets shipyards hoist entire platform modules in one move. Fewer lifts mean less risk, less labor, and schedules compressed by weeks. Underground, the Heron Connect S-Class. Tunnel boring machine advances up to 50 meters per day. Electric drives and hydraulics let engineers steer through shifting geology, while digital systems track every pressure and torque reading. These machines do not just move the impossible, they make mega projects modular, faster, and safer, pushing the limits of what can be built above and below ground. Beneath city streets, tunnel boring machines like Bertha operate where a single mistake can threaten entire neighborhoods. Bertha's cutter head measured 17.5 meters across, wider than a city bus is long, and it packed 22 megawatts of electric power, enough to light thousands of homes. In Seattle, just 300 meters into its drive, Bertha struck a steel well casing hidden in the ground. The impact damaged the main bearing seal and ground its progress to a halt. Crews spent nearly 2 years and tens of millions of dollars digging a shaft 36 meters deep to reach and repair the machine. Every day lost meant mounting costs and public scrutiny, a reminder that even the most advanced machines are vulnerable underground. On the surface, NASA's Crawler Transporter 2 moves at less than walking speed, but it carries the world's largest rockets to the launch pad. Weighing 2,721 tons and spanning 35 meters wide, Crawler Transporter 2's upgraded systems keep a fully stacked rocket level within a fraction of a degree. Each rollout is a high-stakes operation, where a single slip could jeopardize years of work and billions in hardware. A single ship, longer than 3 football fields and weighing 100,000 tons, can project AIR power across any ocean on Earth. This is the scale of the Nimitz and Ford-class nuclear aircraft carriers, floating fortresses powered by twin reactors that each generate hundreds of megawatts. Their construction costs soar past $10 billion, driven by nuclear propulsion, electromagnetic catapults, and the ability to launch more than 70 aircraft from a moving city at sea. Every system, from radar arrays to armored flight decks, is built for endurance and dominance, the result of decades of naval engineering. Beneath the ground in Europe, another kind of giant stretches for 27 kilometers under the French-Swiss border. The CERN Large Hadron Collider is the most ambitious scientific machine ever built. Thousands of superconducting magnets, cooled to temperatures colder than deep space, guide particles to nearly the speed of light before smashing them together with energies reaching 13 trillion electron volts. The collider's price tag, more than $4 billion, reflects not just its size, but the precision required to unlock the secrets of the universe. Together, these machines stand as proof that when ambition meets engineering, limits are meant to be shattered. Right now, these machines are pushing the boundaries of what is possible, reshaping cities, fueling economies, and defining the scale of human ambition. Their cost and power reflect the stakes of every project we undertake today. Because ultimately, our world is only as bold as the machines we dare to build.